Okay, let's do question 294, starting with our homework in case you missed going over it in class. It says sketch a graph of each of the following functions, labeling the key points. Be sure to graph at least 2 cycles. So this means, you guys, 2 cycles means 2 times around the circle, or the word we learned was 2 periods. Okay, so this cycle, why does it keep changing to white? There we go. So 2 cycles, and the word we learned for that were periods. Twice around the circle, once around the circle is a period. So at least twice around the circle. So what I did is I put these all into Desmos, and I'll show you in just a second. But it's just like transforming any other function. At the end, this is going to move our first sine curve down by 2, right? This will move the cosine curve up by 1 if it's just on the outside of the function. If it's on the inside of the function with the x, okay, this is going to move it left and right. Remember, the minus means move it to the right. It's kind of counterintuitive. And the plus means move it to the left. Okay, so it's nothing different than what we've already done. The difference is that when we are graphing these, things, we don't just have an x and a y, right? Our x is actually, we do just have an x and a y. I don't know why I just said that, but I want you to think about the x as an angle. This is where we graph our angle. This is where we have theta, okay? And this is a little bit hard for students sometimes to make that kind of recognition about what's going on. So let's go ahead and head over to Desmos, and this is where I put them in. So this is just the sine curve. And so when we're looking for twice around this, twice 2 cycles, right? And remember, the sine is we are graphing the height. We're graphing the height of the circle. So we start off on a circle when you have your circle here, right? If we're graphing the height of the circle and we start off at 0 degrees, the height right here is at 0. So that matches right here. That's the height right there. At 90 degrees, okay, it's at 1. So this right here, my dog is playing with this squeaky toy. He loves it. I hope you guys, it's not bothering you too much. And right here is 1, right? So this must be 90 degrees. Then it goes back to 0 at 180. So right here, this is 180 degrees. And then it goes down to 1 at 270 degrees. So this must be 270 degrees. And remember, when we're talking about radians, and that's what we need to be graphing this in, we're actually not talking about degrees, right? This is 90 degrees, but 90 degrees is the same as half of a pi. So this is really pi over 2. It goes back to 0 to 180 degrees, which is a whole pi, or half a circle. Over here, this is 2 pi. Okay, so that's my whole circle. So that's 1 cycle. And then it goes up and up and up and down and down and down. And this is 2 cycles. So this is how far it goes. 2 periods or 2 cycles, however you want to think about that. Some other important things are, oops, let's just close this. Let's just close this whole thing down. The other things that we want to look at are, if you click on Desmos, you can see there's pi over 2 and 1, right? Pi 0, 3 pi over 2, and 2 pi or 360, right? Okay, and then up, up, down, down. Gotcha. Okay, so there's all of our points twice around the circle. Twice around the circle. That's what the sine curve looks like. If I click on the cosine curve at the same time, remember, it's all the same points. It's just that, I don't want to click on that. We start, when we're talking about the cosine curve, we're talking about how fat the circle is. So whereas our sine curve starts at 0, 0, because it's not, we're graphing the height, and it's 0 there, our cosine curve is always going to start at 1, and then it comes down, down, up, up. There's 2 pi. There's a whole circle on the cosine curve. So it starts at its highest point, comes down and goes back up. And then if we go once more around the circle, and it goes back up. So 4 pi, yep, twice around the circle. Okay, so that's sine and cosine. And let's leave those up and see what happens with the rest of these. So, well, actually, let's take our cosine off for now. Because the next thing we wanted to graph is the sine of x minus 2. Now remember, that's just going to move the sine curve down 2. So every point just gets moved down 2. It was at 0, 0, now it's at 0, negative 2. This was at 3 pi over 2 comma negative 1, and now it's at 3 pi over 2 negative 3. 3 pi over 2 is 1.5 pi, or 3/4 of a circle, right? Okay, so that's all that did. Now, this is a cool one, and I'm gonna put my cosine back up so you can see. So the black is the cosine, the red is the sine. If I take the sine, so I'm at the third graph right here, I take the sine, and it's gonna move it to the right, pi over 4. So remember, in a circle, guys, pi over 4, if a whole pi is 180 degrees, 90 degrees is half of a pi, or pi over 2, then pi over 4 is 45 degrees. So we are shifting the circle 45 degrees to the right. So what does that look like? Okay, so the green one. So you can see, let me take the cosine off. We took the sine curve and we moved it to the right 45 degrees. We took every point and moved it to the right 45 degrees. Okay, that's all that happened. We shifted it to the right by 45 degrees. So if we look at the points, here we have pi over 2, or 90 degrees, comma 1, and on the green curve, we have 3 pi over 4, comma 1 degree. So a larger angle, same height. Larger angle, same height. So we turned it, when you turn it to the right, we literally turned the circle to the right by 45 degrees. Okay. All right, what's next? Okay, let's go to the cosine. Let's take off all the sines, and we'll just leave our first cosine. And then cosine of x plus 1 shifts every point up 1. And then cosine of x plus 90 degrees should move it to the left 90 degrees. Okay, so if you look here, this was 2 pi over 1. 90 degrees away from 2 pi is 3 pi over 2, comma 1. Okay, so we've tilted that circle, we've moved it to the left. Now check this out, let's do this. Let's say we wanted to take that plus 1 again and put it there. Now I've shifted it 90 degrees to the left, and I've shifted it up 1. So the same thing that you can do with all of those other functions, you can do with the sine and cosine waves. Okay, so on your test, you will only be able to use the TI calculators, but I just think that Desmos, it's so much nicer to see actually what's happening. That's what I wanted to use on the video. So let's look at question number 95. All right, you guys, so question number 95, we're going to start talking about the amplitude. And we did take notes on this the other day, but you probably are not remembering right about now. Because the question 95, this first blue thing was called, we're talking about the midline, and it's the horizontal line that splits the graph of the function in half, right? And then the distance between the midline of the function and a maximum or minimum point on the graph is called the amplitude. So let's go back to our Desmos and take a look. Let's just leave our cosine and our sine here, right? So our midline for just our regular, I'm just going to do one period. It's going to make it easier to see. Now you may be wondering why, if our x is arrows, why they're still using numbers. Well, I just wanted you guys to see twice around the circle is going to be 2 pi, right? So if we went, look at the sine curve, twice around the circle was 2 pi. It starts at 0 here, okay, right? 2 pi comma 0. Well, what is 2 pi? 2 pi is 2 times 3.1415, whatever it is, past that. And 2 times that is going to be 6 point something. So that is why, even though they just use numbers here, we know that 2 pi in this case is going to be 6.28 something. So that's why we have these numbers here, but they actually are represented as 2 pi. So what was this doing? Our midline here is just our y equals 0. It's just this x-axis right here. That's our midpoint. So what it's talking about, the amplitude, is halfway between our distance from our top point to, if you look at just the red sine curve, the amplitude is the distance right here. Okay? It's not all the way down. It's not all the way down to -1, right? Where would be the lowest point of sine, but it's halfway. It's the distance from the midpoint to the maximum, and it's also the same distance from the midpoint to the minimum. Okay, those are both 1. So the amplitude in this case is 1, and the midline of this is going to be y equals 0, which is the same as the x-axis. Okay. So what does it want us to do with this? It says, sketch a transformation of cosine of x that has an amplitude of half. So where does the amplitude go? Where does the amplitude go in our equation? What that looks like is, erase all of this, go away. If we just look at the cosine function, right? And if we add something on the end, it's going to move it up. And if we add something or subtract something from the inside, it's going to move it left and right. The amplitude is the a in a regular function. It's going to stretch it and shrink it vertically. So what we're going to do is we put it on the outside here in front of the cosine. And if we wanted to make it bigger, we would make that bigger. So right now it's just 1 times the cosine of x. We could stretch it vertically by making it 2. Now our amplitude is 2, right? From the midpoint to there's 2. So if I make it 0.5, if I make it half, what it's done is it's shrunk it vertically by half. So where it was 1 right here, now it's at half. 1, 1.5, 2. Okay? So I want you guys to notice though that we have not changed where it crosses the x-axis. When you stretch or shrink something, it doesn't change that. It just stretches the points that are not there. Because remember, if a point is 0 right here, no matter what you multiply it by, it's going to stay 0. Now you can stretch or shrink it horizontally, but we are not going to get to that in this chapter because there's some extra steps you have to do here because of the frequency and the period. So let's just not think about that. Let's just make sure that we know how to stretch and to shrink it.